Welcome to QuantumVR, where we will introduce you to a quantum mechanical version of the hydrogen atom. In this short tutorial, we will be teaching you the fundamentals of quantum mechanics by allowing you to interact with the atom. We will give you instructions and tips to get started, but feel free to take your time getting comfortable with the system and this unique experience. This is our old friend, the hydrogen atom, whom you may have met before. Hydrogen is the first element of the periodic table, and we usually see something like this, a nucleus with a single proton, with an electron orbiting around it. In reality, however, the hydrogen atom actually looks more like this model to the right. This is the quantum hydrogen atom. Despite its appearance, the atom before you contains only one electron and one proton. However, it reflects an important aspect of nature that the Bohr model does not. The electron is spread out like a wave and does not simply exist at a single location. Similarly, the electron does not orbit the nucleus like a planet orbiting the Sun. Instead, it exists all around the nucleus, like a cloud. We will refer to this as the electron cloud. Did you notice some areas have a more opaque color? This tells us that the electron is more likely to be at that location if we were to measure it. If the area is transparent, the electron is less likely to be at that location. From where you're standing, you might not be able to see the atom that well. Let's fix that. Open up your control menu in your hand. This can be done by pressing the highlighted button on your controller. In the control menu, point the laser on your right hand onto the tab labeled Right and pull the trigger to click on the button. This will bring you to the second page of the control menu. Now, click on a button called Auto Rotate. Spinning the model alone may not be enough to see the interior of the atom, so we also have the option to look inside by slicing the cloud open. You can toggle through slicing in the X, Y and Z directions by pressing the Slice Model button on the left page. Try pushing this button a few times. You can even select a different plane to slice on a specific axis so that you can get a very fine-grained view of the model. Try moving the slider under the Slice Model button. With that, we can finally see what's inside. But it appears to be nothing but a singular cloud of red. What you are currently seeing is the lowest energy state of the atom, which is quite featureless. In a few minutes we will look at higher energy states, so remember this ability to slice the model when we get there. Take a look at your control menu once again, and you'll see something labeled Energy State. Attached below is a number with buttons alongside that increment and decrement that number. Change this value a few times and observe the changes in the model. By changing the value of the energy state, you are putting the electron in different energy states. As the energy increases, the electron cloud shifts, telling us that its most likely locations have changed. Another thing you may have noticed when changing the energy state is the wide variety of colors. The colors represent the phase of the hydrogen atom. The final concept we will learn is measurement. When we look at things in the classical world, it doesn't do anything besides letting us see where they are. In the quantum world, measuring things changes their state and leads to wave function collapse. Point the laser at a location on the electron cloud and pull the trigger to take a measurement. Did you see how the electron cloud changed instantly when you measured it? This is the collapse of the wave function in action. The simple act of looking at the electron changes its state. Through your measurement, We have changed the electron cloud to be much more localized around the point where we measured it. Unlike our old model, the electron cloud does not collapse to a single point, so we still do not know its precise location. However, by collecting information from the measurement, we conclude that the electron is highly likely to be near where you just pointed. In fact, by simply measuring it we make this more likely to be true. Right now, the simulation is paused, however you can resume time by selecting the play option in your control menu. While we are on the topic of time, there are additional functionalities you can use to help observe the change a bit more easily. You can change the time evolved parameter in order to either speed up or slow down the change the model makes. Go ahead and lower it so you can see the change. This concludes the tutorial. Even though the main explanation is over, we highly encourage you to continue to experiment with the model with all the options available. When you are ready and feel comfortable with what you learned, you can click the next button to take an interactive assessment which you can take to test your knowledge.